Okay, so today we're going to cover techniques to separate mixtures, and so we're going to go over 4 of them: filtration, evaporation, distillation, and chromatography. So filtration is simply just the splitting of usually solids and liquids in a heterogeneous mixture. And so what you'll notice is just similar almost to like a coffee machine. You'll put a coffee filter paper, and the filter has really small holes that allows the water or the liquid to pass through, but it doesn't allow the solid or the larger particles. So here the liquid goes through and the sand or whatever this solid material gets stuck. And so it's a way to separate solids and liquids. Evaporation is another technique, especially of a homogeneous mixture of solids with liquids. So here this man is actually, what they do is they take seawater and they kind of spread out the seawater in thin layers. And so what happens is the water evaporates, and so the sea salt is left over. And so this is the way to separate the water from the salt or anything that's dissolved in water. The next one is called distillation. It's used mainly when you have homogeneous mixtures. Oftentimes, even with, say, like 2 liquids, you can use distillation. And this is based off of the boiling points. So let me go ahead and show you what I'm talking about. So let's imagine we had a flask with a liquid, and the liquid contains 2 types of liquid. So you have one liquid that's we'll call the red particles, and then you have another liquid we'll call the blue particles. And the difference, or a big difference between these, let me do it over here, between these liquids is that one liquid has a boiling point. So let's say the blue liquid has a boiling point of 100 degrees Celsius, just like water, and another has a boiling point of 40 degrees Celsius. And so a distillation has an apparatus that's hooked up to a second container of some sort, and usually there's some ice water here or something to keep it cold. So what happens is you heat up the liquid substance, so you add heat, and so you pick a temperature between the boiling point of both of those liquids. So let's say we heat up to 45 degrees Celsius. So what this will, at 45 degrees Celsius, the red liquid or the red particles will start to boil, but the blue particles don't, right? And so the red particles turn into gas, and so they move along the you kind of trap it, so to speak, right? And so they move along here. And so what you end up with is just red particles, because remember, the blue particles are still stuck because they have not boiled. And so you have this red liquid. Now the ice water is used to kind of recondense or condense the gas into the liquid form again. And then over time, as you boil it off, the red particles leave in gas form and recondense over on the right hand side, and then so you're just left with blue particles. So now you've separated this mixture into the 2 components. And then the last one is chromatography. So chromatography is when you use basically water or some type of solvent is used to kind of push a solute. In this case, a lot of people use like pigments, some type of color, and so it'll separate it by pushing the pigments up the filter paper. And as it pushes it up the filter paper, some of the pigments or some of the some of the pigment here, like this yellow pigment, is actually a little more attracted to the stationary phase, which is the paper, and some of the color is actually very soluble in water, so it has a higher attraction to the solvent or the water. And so what happens is they separate because some of them are more attracted to the paper and some of them are more attracted to the water. So the water, the pigment or the solute that is more attracted to the water will actually travel with the water, while the solute or the pigment that is not as attracted to the water will be kind of held up by the stationary phase or the paper. And so you can actually calculate this using what we call a retention factor formula. And so the retention, we call the RF, is equal to the distance of the solute, which is in this case the pigment, over the distance of the solvent. And so this is what we did the lab on today, which is Monday.